will explore the basis of vectors, quantities that combine direction and magnitude. Let's dive in.
Interpreting vectors. Learning objectives. Define vectors in their components. Perform vector operations. Addition and scalar multiplication. Visualize vectors in 2D. Understand vector applications. Here's what you learn. What vectors are, how to operate on them, how to visualize them, and where they show up in real life. First of all, what is a vector? A quantity with both magnitude and direction. Can be represented as an arrow in space or an ordered list of numbers. A vector is not just a number. It points somewhere. Think of wind speed. 20 miles per hour north. That's a vector. Vector notation. A vector v in 2D can be written as v is equals to x and y, or as v is equals to xi plus yj. It has components that describe movement along axis. We use notation like v is equals to the quantity of x and y, or v is equals to xi plus yj to describe vectors. Each part tells us how far the vector moves in each direction. Let's move on into vector addition. Vector addition means adding the x components together and the y components together. It's like combining steps in a path. For example, the quantity of 2 and 3 plus the quantity of 1 and 4 is equals to the quantity of 2 plus 1 and 3 plus 4. And their product is the quantity of 3 and 7. Scalar multiplication. Scalar multiplication stretches or shrinks a vector. Multiply each part by the number to get the new vector. For example, 2 times the quantity of 3 and 4 is equals to the quantity of 6 and 8.
Let's consider two vectors. Vector A is equals to the quantity of 2 and 3, and vector B is equals to 4 and 1. Let's have an example of a scalar multiplication. Multiply vector A by scalar 3, and 3 times vector A is equals to 3 times the quantity of 2 and 3 is equals to the quantity of 2 times 3 and 3 times 3. It's equals to 6, quantity of 6 and 9. Let's have an vector addition. Add vectors A and B is equals to the quantity of 2 and 3 plus the quantity of 4 and 1 is equals to the quantity of 2 plus 4 and 3 plus 1. The product of that is 6 and 4.
Let's move on to visualizing vectors. Vectors can be drawn as arrows from the origin. Addition forms a parallelogram shape. I'll provide an image so that you can make visuals to the origin shows where vectors go. Let's move into applications of vectors. Vectors are used in so many areas, from calculating forces in physics to moving objects in computer games. For such example, physics, force and velocity, computer graphics, navigation, machine learning. And that's the examples of applications of vectors. To summarize, vectors describe direction and size. You can add them, scale them, and use them everywhere in science and technology. That's all. Thank you for watching. Thanks for joining. Keep practicing, and you'll see vectors all around you. Don't forget to like and subscribe for more.